Hello there, class. This is Mr. Brooks. I'm going to go through these notes for today. If you were not here or if you're coming back to make sure that you understand what we did today in class, this should be posted on Google Classroom for you to access, as well as on my YouTube channel and my website for you to access as well. So let's get into this. Today what we're doing is we're finding something called distance, okay? We've spent a little bit of time talking about points and lines and planes and all of these algebra steps we did with line segments even. Today we're kind of starting this new topic for our unit on tools for geometry, where we're using distance between points. And so let's kind of get into this a little bit. If I have a line, and I have 2 points on that line, we can just call those A and B. Well, A and B are some distance away from each other. Or in other words, from A to B, I can find the length between them. And well, let's just say A is here at -5. I'll say here's about 0-ish, and then B is over here at 6. Okay? Well, how do we find the distance from A to B? One step, well, we could just maybe count -5 over to 6. That could work if we had a number line. But another thing we could do, and this is the traditional way of doing this, is we're going to take the largest of my numbers. I'm going to take B. I'm going to take 6. Okay, it's my largest of my numbers. And I'm going to subtract it with the smaller of my two numbers, minus -5. And if we remember our integer rules, if we have two negatives, that makes a positive. So 6 plus 5 is 11. Okay? And what this tells us, if we have our first number, I'm just going to call that x with a tiny little 1. That's just our starting point. And we're going to our ending point here, x2. Then we know that the distance between these points, x1 and x2, can be written as x2 minus x1. That's our distance. There we go. That's our distance. To break that down, to slow down a little bit, we have a start, we have an end. To find the distance, take my ending point, subtract it with my starting point. If it's double negative, it goes positive, and I get my distance. Now I want to kind of clarify something important here. Suppose that I had something negative come out for my distance, something like -11 instead. What do we do here? Because realistically, there's no such thing as a negative length. Well, what I could do is make sure that it's always just the positive version, right? We talked about that a little bit a couple weeks ago, but absolute value, right? Absolute value are just two lines up and down next to a number, and all that means is whatever number is there becomes positive. So if it's -11 in absolute value, it's actually positive 11. And so what that lets me do here is if I put absolute values for my distance, then it will always be positive and I'm good to go. Okay? Now here's where we're getting to. This is really nice if we just have a line going from left to right. Okay? That's handy. But we don't always just have a straight line that goes left and right. We also sometimes might have 2 points that go more diagonally than up and like left and right, you know. And so if we think about this, we're going to always have that happen in a coordinate grid, in a plane, right? Where we have our x's and we have our y's. We're not just moving left and right anymore. We're also going up and down. So how do we handle this? Here's where I want you to go to the top left of your notes. The distance between 2 points, so I'm going to underline some things. The distance between 2 points on a coordinate grid. In other words, something that looks like this, where I have my arrows going in all four directions. I have x's and I have y's. Can be found using something called the Pythagorean theorem. This might be something we've heard before, but we're bringing it back, right? Well, the Pythagorean theorem is a squared plus b squared equals c squared. Specifically, when I have a right triangle, like this, a right triangle, notice it's a right triangle because it has the square right here, it's 90 degrees, with A and B forming the legs, and C being my hypotenuse, or just that other side that's farthest from my 90-degree angle. Let's think about this. If I have this situation from one point to another on a coordinate grid, something kind of like this, I could measure from x1 to x2. Because notice, all I'm doing here is this is my x-axis, this is my y-axis. I want to make sure I make this clear. This is my starting x, and this is my ending x. So same sort of thing I just did, x1 to x2. My y's go from y1 all the way up to y2. I'll make sure I can zoom in here so it's very clear what I'm doing. My y starts at y1 and it ends at y2. My x's start at x1 and end at x2. So the distance, right, the length of my x's is x2 minus x1. That's what we did the first time, right? And this is going to represent one of my sides of my triangle. I'll call it A. The other one I'm going to call B, and then, as stated before, the long way across that diagonal, I'm just going to call that C. Well, I go from x1 to x2, so there's my distance. And then I have my changes in my y's, right? For B, B is just the changes of the y's, y2 minus y1. But wait, if I have A, B, and C, why can't I just use my Pythagorean theorem, right? A squared plus B squared should equal C squared, right? That's what the Pythagorean theorem says, where this is x2 minus x1, and up and down is y2 minus y1. But I don't want C squared, I want C, so I have to take the square root of both sides. C has to be the square root of x2 minus x1 squared plus y2 minus y1 squared. And this is called the distance formula. So if you want to write this in things you don't want to forget and copy it down again, you're welcome to. Distance, there we go, distance with the coordinate grid is equal to the square root of x2 minus x1 squared plus y2 minus y1 squared. That's distance. So let's work with this a little bit. We have our formula we can use. Let's try to find, adjust it here. Let's try to find the distance between A and B. Okay? A has -6, -4 for its coordinates, and B has 5, 9 for its coordinates. As a reminder, if it's been a little bit, if I have coordinates, it's always written as x, comma, y. Okay? So 5 would be the x for B, 9 would be the y for B. And same thing here, -6 is x, -4 is y. So now I need to find the distance. I'm going to say the distance D is the square root of x2 minus x1 squared plus y2 minus y1 squared. So now we need to make a choice. I always like to start with my smallest. That's going to be my x1, y1. So negative 6 is smaller. I'm going to go x1. And y1 is going to be the corresponding y value that goes with the x. So if I have x1 is negative 6, y1 has to be negative 4. That means I have x2 is 5, y2 is 5. Or 9, excuse me. x2 is 5, y2 is 9. And now I have everything I need. I just plug it into my formula. x2 is 5 minus x1, which is negative 6. And again, I just like to put the parentheses to make it clear that it's negative. I'm going to take that and square it, plus y2, which in this case is 9, right? y2 is 9, minus negative 4 squared. And then all of this is going to be under a square root by the end. So 5 minus negative 6, well remember, double negative makes a positive, so I have 5 plus 6, well that's just 11 squared. 9 minus negative 4, same situation. Double negative goes positive, so 9 plus 4 is 13. I'm going to square that, and at the end, take the square root of the whole thing. 11 squared, that's just the same thing as 11 times 11. And you're welcome to use a calculator on that part. You're going to get 121. And then 13 times 13, same situation, it's going to be 169. I add the 2 and take the square root. So 121 plus 169, I'm going to add those. 9 plus 1 is 10, I'm going to bring up the 1. 6 plus 2 is 8, plus 1 is 9, 1 plus 1 is 2. So I should have the square root of 290, and I can leave this as my answer, because that is just a number, it's just within a square root. If I'm looking for like the precise exact answer, it's about 17. And you can use a calculator to verify that, but that's the process we do. If we break down the steps, first we choose x1, y1, x2, y2. We plug the values into their corresponding places in the formula. We simplify the parentheses first. Then we do the exponents, right? PEMDAS, parentheses, then exponents. Then we add together, and then take the square root at the end. So that's our steps. Last one, we're going to do example 2. So let's find the distance between j and k, where j is 4, 3, and k is negative 3, negative 7. Again, I like to go with the negative numbers, these smaller numbers first. So I'm going to say x1, y1. Again, I just need to make sure they're matched. And that makes 4, 3, x2, y2. My formula, distance, is the square root of x2 minus x1 squared plus y2 minus y1 squared. So now I plug them in. x2, well I have 4, minus x1, which is negative 3. 4 minus negative 3 squared plus y2. y2 is 3 minus y1, negative 7 squared. And at the end, I take the square root of the whole thing. 4 minus negative 3, double negative is a positive. Well, that's 7, and I'm going to square it. 3 minus 7, well, that's 3 plus 7, so that's 10 squared. And I take the square root. 7 times 7 is 49. 10 times 10 is 100. Add them together and take the square root. 49 plus 100 is 149, square root, which is about 12 and some change. But again, I can just keep that answer. That works for me too. So, thank you guys for watching. Hopefully this was helpful. Please slow down or go back if you need to go and understand something better, or email me and ask questions so I can help support you. Thank you so much for your time. I hope you have a great rest of your day.